Okay, hello and welcome to the exam review video for Algebra 1 semester exam. I'm going to quickly go over which days everybody has their exam. So let's see, let me go ahead and highlight. These are the actual exam days. Okay, so for every class period, your starting day is in green and your finishing day is in red. So what that means is first period and seventh period, you are starting tomorrow on Friday the 13th. Friday the 13th, spooky. And you are going to be finishing on Tuesday the 17th. Second period, you're starting on Monday the 16th and finishing on Wednesday the 18th. And third and fifth period, y'all are both starting on Tuesday, finishing on Thursday. Sixth period, you're starting on Wednesday, finishing on Friday. So I'll go ahead and take all those markings away so y'all can see the calendar again. Okay, so there you go. All right, so starting off with systems of equations, which again is unit 5, which is the unit that we just finished. So we've got a word problem, and as y'all have heard me say in class, when I'm approaching a word problem, I'm gonna be reading it looking for the variables. So let's see, Paul ordered 3 new swimsuits. Okay, so 3 new swimsuits and 2 pairs of flip-flops for the summer. The price of each swimsuit, S, okay, found one. Price of a swimsuit is S, was 1 less than 2 times the price of each pair of flip-flops, F. Okay, so I found another one. Okay, Paul spent a total of $93, and it wants me to write a system of equations to represent this situation. So, a couple things that I noticed right away is that it wants me to write a system, and that means more than one. So I'm gonna have 2 equations going on here. So the first one, I'm going to use what I've underlined in red. And before I do that, let me go ahead and define my variables. Okay, so my variables are S, which is the price of a swimsuit. And it is not enough for me to just say a swimsuit. I have to know what aspect of the swimsuit I'm finding. Like, is it the price? Is it the number of swimsuits? Is it the weight of a swimsuit? I have to specify that is the price of a swimsuit. Likewise, F will be my price of a pair of flip-flops. Okay, so that's kind of like, it's kind of like an abbreviation. Anytime I want to talk about the price of a swimsuit, I say S. Anytime I say F, I'm talking about the price of a pair of flip-flops. Okay, so now I can look at my information. I know that Paul spent a total of $93, so I know I'm going to have an equation for total price. So what I'm about to write down in purple is not actually part of what I would write down on my paper. It's just, I'm just gonna be like showing y'all my thought process. I know that part plus part equals total. And I know my parts are price of swimsuits total and total price of flip-flops total is equal to price total. So for the swimsuits, he's buying 3 swimsuits, so he's paying for a swimsuit 3 times. So that's 3 times S, which is price of swimsuits, plus 2 times the price of a pair of flip-flops is equal to $93 total. So got my first equation done. Now my other equation is gonna come from the other piece of information they gave me, which was that the price of a swimsuit is 1 less than 2 times the price of each pair of flip-flops. Okay, so I kind of explain it using like grammar here. So like the subject of my sentence is the price of a swimsuit, which I know that I described using the variable S. And I know that that's equal to 1 less than 2 times the price of a pair of flip-flops. So to take 1 less than something, I do something minus 1. In this case, I'm doing 2 times the price of the flip-flops minus 1. And how do I describe the price of the flip-flops? I use the variable F. So that's going to be 2F minus 1. So to translate, price of swimsuit equals 2 times price of flip-flops minus 1. Yes, that does check out with what it told me. Okay. So since it only told me to write the system of equations, it did not tell me to solve, I am done. Boom. Wonderful. Okay, so now number 2, again, talking about system of equations. So it wants me to write a system of equations that represents this situation, and I'm even like pretending that I haven't even read the problem yet. I just want to know what it's going to be asking me. Okay, so in this case, system again means more than one equation, and let's read the problem. So Blake is researching 2 shaving kit subscription services, and the table shows the relationship between the number of months, which is M, okay, got it, and then total cost, which is T, for shaving kit A and shaving kit B. And okay, so that's the relationship that it wants me to write a system of equations for. Got it. So you notice here that like even though it's a quote unquote word problem, the words didn't tell me anything about the relationship between the months and the total cost. Like there are no numbers in my like word problem. The numbers are in my table. So all I'm doing here is writing an equation based on our table. So, I mean, the person who wrote this question probably should have said the word linear relationship, which makes me think of y equals mx plus b. So I'm looking for a y equals mx plus b for shaving kit A. And then I'm looking for another y equals mx plus b for shaving kit B. Okay, so this table over here is kind of like having 2 tables in one. So this is going to be my months, which is M. I'll think of it as my X because it's my input. Then I have 2 different outputs. I've got the first Y and then I've got my second Y. If I want to start by finding the equation for shaving kit A, then shaving kit B is like totally irrelevant to me. I don't even want to look at that right now. It's irrelevant. I'm only looking at this and this. So I need the y equals mx plus b. So I'm going to start by finding my slope, which is y2 minus y1 over x2 minus x1. So I'm going to go and I'm going to pick 2 points. I'll pick this one and this one. So I've got x1, y1, x2, y2. So plugging that in, I get m equals 19 minus 6 over 2 minus 0. So I get here, that's 13 over 2. So that's, since I'm talking about money, I'll use decimals. That's going to be 6.5. So got my M. Awesome. And then for the B, we know that the y-intercept is always 0, number. And I am so lucky here. I actually do see 0, number. So I know that my B is going to be 6. So bam, bam, my first equation is y equals 6.5x plus 6, because here's my M and here's my B. So I'm going to do that one more time. That's it. That's all that the system means. I'm just going to do the same thing twice. So this time, let me erase everything that I have so far. This time, my shaving kit A is irrelevant to me. I don't care about shaving kit A. I want to look at shaving kit B. So once again, let's find our slope. I'll use the same 2 points to the top 2, 0, 0, 2, 15. So x1, x2, y1, y2. So here my slope will be y2 minus y1, x2 minus x1. So I'll get 15 minus 0 from here and here over 2 minus 0. So that's 15 over 2, which is 7.5. So there's my M. And then again, luckily I do see 0, number. So my B is 0. So technically, if I plug in everything that I see, I would get y equals 7.5x plus 0. And that would not be wrong. That would not be wrong. But again, adding 0 does not change the value of something. So I can just say that's y equals 7.5x. So these 2 equations together will form my system. Boom, done. Okay, very similar is number 3. This time I'm going to be doing the exact same thing, exact same goal. But instead of doing it from a table, I'm doing it from a graph. So I'll hit my positive slope first. So I'll do this line in red. Okay, so I know that I need to find my slope. And on a graph, my slope is my rise over my run. So I need to find 2 pretty points. And like I think I said this at all my classes, but just in case, the ones that I always look at first are the x-intercept, the y-intercept, and then the point of intersection. So if I zoom in really close right here, that's actually not a pretty point. It looks like it goes through about 7.5 maybe. So let's see, I'm gonna move on. This one looks good though. I do like that. And then this one looks good as well. So my rise is I go up 2, so positive 2, then I'm going to the right 5, so positive 5. So my slope overall is 2/5. Okay, and now my y-intercept, I know that this is the y-axis, so my y-intercept is right here at -3. So my b is -3. So altogether, this equation would be y equals 2/5 x minus 3. Oops, 3. Okay, cool. Now do it again. For my line right here, again, I'm going to use this same point because I already know it's a pretty point. And I'll use, yes, the y-intercept looks pretty good. So here, my rise is, 3 jumps, but I'm going down by 3. So my rise is actually -3. And my run is also 5. So my slope is -3/5. And then again, my y-intercept looks like -8. So my equation altogether would be y equals -3/5 x minus 8. So this would be my system of equations altogether. The number one mistake that I'm already anticipating seeing is people who forget to write that negative. So I know that y'all are counting hops, but remember to think about which way you're traveling. So that is number 3. Okay, number 4. So another system of equations, another word problem. I'm going to read through this and I'm going to look for variables. Let's see. The manager of a gas station purchased a total of 21 coffee mugs and keychains. Okay, so that's the total combined. Each coffee mug cost $8.50. Let's see, each coffee mug costs that much, and each keychain costs $2.75. If the store manager spent a total of $132.50, how many coffee mugs did the manager purchase? Okay, problem. They did not give me variables. I don't see any X and Y. I don't see any B and D. I don't see anything, but that's okay because I do know what I'm being asked to find. How many coffee mugs? Okay, so if that's what I need to know, that's gotta be one of my variables. In other words, gotta be one of my unknowns. So I'm gonna make this easy for myself. I'm gonna say that C, you know what, that kind of looks like a parentheses, so maybe use M can equal the number of coffee mugs. And again, that number of is super important. I already know the price of a coffee mug. It's $8.50. I'm trying to find the number of coffee mugs. Okay, and then the other thing that I don't know is I'll use K to mean the number of keychains. Okay, so now that I know what my variables mean, I'm ready to use them in a sentence or an expression. So the first thing that I know about this manager is that the manager purchased a total of 21 coffee mugs and keychains combined. So I have a total. I love having a total because I know that part plus part equals total. Okay, and then here, let's see. It told me the total already. So the total number of items is 21. So that's going to be the number of coffee mugs and the number of keychains add up to 21. Okay, well, how do I say the number of coffee mugs? I use M. How do I say number of keychains? I use K. Awesome. Equation 1 done. I also know that I have a total of $132.50. So now I also know the total cost. So again, the cost of a coffee mug plus the cost of a keychain, I'm drawing a little picture, equals the total cost altogether. So my total cost is $132.50. And how do I find the cost of the coffee mugs altogether? Well, I don't know because I don't know how many I bought, but I do know that however many coffee mugs I bought, I'm paying $8.50 for each one. So that's $8.50. I'll say 8.5 times M, which is the number of coffee mugs that I bought, and plus $2.75 times K, which is the number of keychains that I bought. So altogether, I have found my system of equations. So I'm gonna go ahead and put that maybe in brackets or something, just show myself that it's important. And here, I'm not done because it didn't want me to just write it. It actually did want me to solve it. It wants me to know how many coffee mugs we bought. Okay, so if I'm you guys, I mean, there's two good ways to solve this. I'm going to do the one that I like better, which is elimination, because I also know that I have like terms lined up already. And I know I'm being strategic here. I want to solve for coffee mugs, which is M. So I want to end up with M equals, which means I have to eliminate K. So let's see. Up here I have 1K. Down here I have 275K. So to make them cancel out, let's see, I maybe want this to be a negative 2.75K. So let's see, I'm actually, you know what, I'm gonna take a minute, I'm just gonna rewrite my equations over here because my thing is getting a little bit messy. I've got M plus K equals 21. I've got 8.5M plus 2.75K equals 132.5, 0.50, but I'll just say 0.5. And I'm trying to eliminate my Ks. So these are the amounts of K that I have already. I want this to be a negative 2.75K. So I'm gonna multiply this whole equation by negative 2.75. Okay, so let's see what I get. I get negative 2.75M minus 2.75K equals, let's see. Even I am going to use a calculator for speed here. Okay, and then I got negative 2.75 times 21. Okay, so negative 57.75. Cool. Oops. Okay, so now let's go ahead and combine. I know that I've got 0K. Awesome, that was my goal. And then let's see, 8.5 minus 2.75. Okay, this one I will do mentally. I get 5.75 M equals, okay, let's see. Now I know how you guys feel. I'm trying to be fast here. Okay, for speed, I'll use my calculator. Let's see, 132.5 minus, 132.5 minus 57.75 equals 74.75. I'm going to divide both sides by 5.75. Sorry. There's the bell in the background. Apologies. Okay, let's see. Let's see if I can estimate correctly. That's about 6. That's about 75. I'm going to guess about 11. That's my guess. Okay, let's see if I'm right. 5.75. Ooh, I was close. Okay, 13. Okay, so there were 13 coffee mugs that this manager bought. 13 coffee mugs. Done. Okay, so say that I had actually solved for K instead. Let's see. Or let's say that we're asking me for K, like the number of keychains. Then I would go back and I would plug in 13 for M, so 13 plus what equals 21. I would take away 13 from both sides, and I get K equals 8. So there were 13 coffee mugs and then 8 keychains. Okay, cool. All right, let's see. Now on to number 5. Oh, yes, feeling blessed. This is a nice, bare problem. No words involved, just math, just numbers. Amazing. I'm pretending that I'm you guys right now. Okay, so let's see. This is set up currently to use substitution because I already know that x is by itself. I know that x is equal to negative 2y plus 9. So anywhere that I see an x, I can put this instead. So in my other equation, I'm going to go ahead and rewrite it below. I've got 6y plus x equals negative 59. Okay, but I know that I can replace x. I can replace it with this whole thing. So instead of writing 6y plus x, I'm going to have 6y plus negative 2y plus 9. Still equal to negative 59. So this right here turned into this because those two things are equal. Okay, so now let's solve this for y. Okay, so we're technically distributing a positive 1 right here. So I've got my 6y just hanging out for later. Then I get negative 2y and then plus 9 equals negative 59. Since these are already on the same side, I'm just combining my like terms. So I get positive 4y plus 9 equals negative 59. I take away 9 from both sides. 4y equals negative 68. I divide by 4. And I get, let's see, 15 plus 2, negative 17. Okay. Cool. Halfway there. Technically more than halfway, depending on how you look at it. Okay, now I'm going to plug that back into either equation. In this particular case, I think I like the bottom one better. So I'm going to go ahead and take that down here. I'm just rewriting it. I've got x equals negative 2 times y plus 9. And I know that y is negative 17. So x is really equal to negative 2 times negative 17 plus 9. So that means that x is equal to 34 plus 9. So x must be equal to 43. Amazing. So my solution is 43, comma, negative 17. Okay, and I'm pretending that I'm you guys, so that means that I'm checking my work. So let's see. Oh, and I didn't check my work on here. Oh, how terrible. Okay, I think I did this with you guys in class, so just for time, I'm not going to check my work on number 4, but I will on number 5. So I get 43 store into x, and then negative 17 store into alpha y. Okay, let's see. 6 alpha y plus x. I'm getting that from right here. I should get negative 59, which I do. Cool. And then here, x is equal to 43. So negative 2y, alpha y plus 9. Oh, I didn't put a negative. Negative 2 alpha y plus 9. I should get 43 as well, which I do. Cool. So I have checked my work. Okay, last one for the solving systems of equations section. Let's see, number 6. A bus travels 2 different routes, the green route and the blue route. The routes are different lengths. Cool. On Monday, the bus traveled the green route 6 times and the blue route 5 times for a total of 52 miles. On Tuesday, the bus traveled the green route 12 times and the blue route 13 times for a total of 119 miles. What is the length of the green route in miles? Okay, once again, it did not give me variables. It's making me do that on my own, but I can do that. That's easy. I know that I'm trying to find the length of the green route. So that's got to be one of my unknowns. I'll use G for green. So green equals, or G equals, I'm not writing green route, I'm writing length of green. And I'm going to be lazy. I'm not even going to write the word route, just length of green. The other thing that I don't know is, we'll call it capital B, is length of blue route. Okay, cool. So now I'm ready to write my expressions. All right, so this is broken up really nicely for me. I've got one equation for Monday, one equation for Tuesday. Monday and Tuesday. So on Monday, the bus traveled the green route 6 times. So how long will that be altogether? Well, I don't know, because I don't know how long the green route is. But I know that however long it is, which is G, I'm going to be traveling it 6 times. So 6 times however long the green route is, plus 5 times however long the blue route is, will make 52 miles total. Then on Tuesday, the bus traveled the green route 12 times, so 12 times the length of the green route, plus 13 times the length of the blue route equals 119 miles altogether. Okay, and then I would love to be done, but I'm not done because it wants me to solve. Find the length. So let's see. I want to solve for the length of the green route, so I want to end up with G equals, but right here, G is just so much more easy to eliminate than B is, so I'll do it the long way around. I'm going to eliminate my G's. So a common multiple of 6 and 12 is, of course, 12. So I already have my positive 12G, so to make this one my negative 12G, I've got to multiply everything by negative 2. Okay, so let's do it. We get negative 12G minus 10B, equals negative 104. Cool. And then here I already had the positive 12g that I wanted, so I'm just going to take that over as is. So 12g plus 13b equals 119. Oh boy, equals 119. Now let's combine. So 0 g's. Altogether I have 3 b's equals 15 miles. Divide by 3. The blue route is 5 miles long. Okay, done, right? No, not done. I don't want to know how long the blue route is. I want to know how long the green route is. Oh, okay, so let's go back. I personally like the top equation better. It's just a little bit smaller numbers. So we've got 6g, plus, what was it, 5b equals 52. Now I know that the length of that blue route is 5 miles. So really that's 6 times the green route plus 5 times 5 equals 52, because I know that b is equal to 5. So 6g plus 25 equals 52. Take away 25 from both sides. 6g equals 27. Divide by 6, divide by 6. G is equal to 4.5. So that's what this is equal to right here. So the green route is 4.5 miles long. Awesome. Okay, and that concludes our system of equations section for the exam review.